All right, today I'm going to go into the special right triangle, the 30, 60, 90 special right triangle, how it's derived and where the special ratios come from. So the 30, 60, 90 special right triangle begins with this triangle here. This is an equilateral triangle. It's probably one of the first shapes you learn, even when you're like 4 years old or preschool when you start learning shapes. A lot of times the triangle that you start off with is one that has equal sides. So the equilateral triangle is where we start. Just for calculation purposes, the length that we use on each side will be a 2, and then you'll see why after we start bisecting. All right, so we start with a 30, 60, 90 degree triangle with every side length of a 2. So what happens with this triangle is we split it right down the center. So I'm going to draw like this dotted line straight down the middle of it like that. And then what I did was I just bisected the triangle. So what I'm going to do is pull one part of this triangle over to the side, and we're going to focus on that one triangle. And then all of the special ratios come from there. All right, so I'm going to take that half of the triangle and come straight this way. Now, we know that this corner is 60 degrees. Anytime you make that L shape, we know that's a 90-degree angle. So what that leaves us with is 30 here in the top corner. So now we have our 30, 60, 90-degree triangle. The other thing that we do know is, remember, because the side length is 2, we know that this hypotenuse is automatically a 2 because all we did was move it from there to here. Now down here is now 1 because we split this bottom one in half. So we split 2 in half. So now I got 1 on this side. My hypotenuse is a 2. The question is, how do I get that height? And if you know anything from geometry, anytime you have one missing side on a right triangle, Pythagorean theorem will give you the missing side. So now I have my leg squared plus my other leg squared is equal to my hypotenuse squared. So question mark squared plus 1 squared is equal to 2 squared. And then we're going to solve for that question mark. Any other time we'll use like an X variable or whatever. I just like to use my question mark when I explain this. All right, question mark squared plus 1 is equal to 4. Subtract 1 on both sides. Now I have my question mark raised to the second power equal to 3. And remember, anytime we have a second power on something, the way that we undo that is by doing a square root. Once you do that, now I have a question mark all by itself is equal to a square root 3. And that's how tall that length is from the bottom all the way to the top corner. It's a square root 3. Square root 3 now. So now I know my special ratios. The special ratios that I have on my triangle is a 1, a 2, and a square root 3. We're going to talk about where they are supposed to go at all times. And from there, it actually allows you to have extremely quick calculations without having to go through a lot of steps. So when we have a 30, 60, 90 degree triangle, you have to be able to distinguish between the shortest leg and the longest leg, right? So you have a short leg, you have a long leg, and then you should always know where your hypotenuse is anytime you have a right triangle. So short leg, we have a long leg, and we have a hypotenuse. So I'm going to show you how you can use this information to make extremely quick calculations. All right, so the key is the short leg. To go from a short leg to hypotenuse, or to go from a short leg to long leg. Literally, to jump from this length to that length, you double it, times 2. To jump from this length to long, you multiply it times the square root 3. Literally, that's all you have to do. You multiply times 2 to get to the hypotenuse. You multiply times square root 3 to get to the long leg. That's what this diagram explains. All right, now, if you're at the hypotenuse, to go back to the short leg, all you need to do is divide by 2. If you're at the long leg and you need to get to the short leg, all you have to do is divide by square root 3. See how multiplying goes out, dividing comes back in. All right, multiplying goes out, dividing comes back in. So here's an example of what can be asked of you if you have a 30, 60, 90 with one side given. Now you have two missing sides. So the Pythagorean theorem works if you have one missing side, but not if you have two missing sides on your right triangle. But because this is a special triangle, that's still enough information to figure out the whole triangle. So just like I did on the visual diagram, I circled my short side and I labeled everything also. So I know where my short leg is, and all I do is draw my arrow. Now remember, if I'm going from here to here, from short to long, all I do is multiply times the square root 3. And 4 times square root 3 is 4 square root 3. So literally my height there is a 4 square root 3 because I multiplied 4 times square root 3. Now, if I'm going from the short leg to the hypotenuse, which will be this way, remember to go from the short to the hypotenuse, I double it. So basically my hypotenuse should be an 8. And by using like simple arithmetic, multiplication, I figured out the whole triangle, no calculator needed, and it doesn't take a lot of brain power to work these out. And believe it or not, this is true, and here's the proof. I have my leg squared plus my other leg squared is equal to my hypotenuse squared. Now, if these answers were wrong, this would not be a true statement, all right? So a true statement means what we did was correct. If I do this, I get a 16. If I raise this to the second power, I get a 48. And if I do 8 to the second power, I get 64. I bet if you do the addition that this is equal to 64. That's how we know it's correct. All right, so I have another example I just put on the board. I'm making the numbers work out pretty nicely by using even numbers when I need to. I'll probably do one more example where the numbers don't come out as pretty, but the process still works. So let's bear with this one for a second. So we have a 14. This 14 happens to be my hypotenuse. So I label that. I need to find which one is my short side. And it's kind of easy. If you know where the smallest angle is, you're just going to go all the way across from it. The smallest angle is always across from the smallest side, which makes this side right here my long leg. All right. All right, so I have my hypotenuse, my short leg, and my long leg all labeled. Now remember, short leg is the key, but I have to go from the hypotenuse to the short leg. So remember, to go backwards, we divide by 2. Remember, we have to divide by 2. So if that's the case, I go from 14, divide by 2, gives me a 7. Now that I know this number, now I can come around to this one. But remember, to go from short to long, you times. And you times by square root 3. So 7 times square root 3 is 7 square root 3. And these literally take seconds to do once you get used to dividing and multiplying by the correct number. All right, so here we go. We're going to verify using Pythagorean theorem. A squared plus b squared is equal to c squared. There's my short leg, 7 squared. That's 49. All right, so if you're not catching on to what just happened here or how to calculate this quickly, this to the second power is 49, but this to the second power is 3. So if I'm raising this whole thing to the second power, basically I'm doing a 49 times a 3, which happens to be 147. So that's 147. Then I continue on with my 14 times 14, that is 196. Now, if you add those two numbers up, it should be equal to that number. And if that's the case, we have the correct solution. True statement. All right, anytime you're dealing with diagrams, make sure you label everything with the proper titles. It always keeps you on track because we always like to reorient our shapes, turn them in different directions. So the labels is what's going to guide you to the right path. So I have everything labeled, long, short, hypotenuse. Now, I need to get to that short leg first. If I don't give you the short leg first, you get to it first. That's the main point. And if you do that, you'll always be on track. So if I'm coming here and going backwards, remember, I have to divide. And since this is a long leg, I'm dividing by square root 3. So that means my short leg is 4 divided by square root 3. So now I know my short leg. We're going to simplify that stuff later, but right now we're just going to leave it at 4 divided by square root 3. Now to go from my short leg back to my hypotenuse, all I do is double that. So that means I can multiply this number at the top. So that means this is going to be an 8 square root 3. And there it is. There it is. All right, so I'm going to verify this one on the calculator. There's my short leg squared plus my long leg squared. I put it in the simplified version, and I got a 64 over 3. When I take my hypotenuse and square it, I also get a 64 over 3. So that means this whole statement is a true statement because this gives me a 64 over 3, and this also gives me a 64 over 3. It's been verified. And it only takes seconds to do it, all right? All you have to do is know when to multiply and when to divide and what numbers you're going to use when you multiply or divide. Those are the two things you got to do. It's straight arithmetic. There's nothing really complicated about it. I hope that made sense because that's all there is to doing a special right triangle when you're dealing with a 30, 60, 90. Number one, you have to recognize it's a 30, 60, 90. If you don't know it's a 30, 60, 90 triangle, then you won't go that quick route. So number one, you do want to recognize it's a 30, 60, 90 degree triangle. Number two, know where your short side is, know where your long side is, know where your hypotenuse is. So the second thing, know all your labels. If you know your labels, you're good. The third thing, know when to multiply, when to divide, and which numbers you're using when you multiply or divide. Once you get those three things out the way, I can give you any triangle. And remember, we can do this a variation of ways. But no matter how these triangles are given to you, if you're dealing with that special right triangle, the labels and knowing what to do, it doesn't matter. You could do all of them.